You may begin.
Hi. Hello, everyone. Welcome to Containers, Engines, and Whales, an introduction to Docker Talk delivered to you by myself. I'm Nathan LeClaire. I'm an employee at Docker Inc. I'm going to get a little bit into what my role is here and why I'm, credentialed to speak about Docker. And today we're going to be going over a little bit of the Docker 101, kind of the basics of what it is and why are people so darn excited about it. And then I'm going to kind of show you a little bit of actual usage on the command line, and it's going to be a great time. So hopefully you can walk away with kind of a renewed, fresh perspective on what it is and what it actually looks like to use and why are people so excited about this new technology. So without further ado, here's Containers, Engines, and Whales, Docker 101. So welcome, everyone. I wanted to let you know that we really appreciate you being here. It's really, really important that the Docker community continues to grow and gets new users and people who are interested and excited about it, and feedback from people like you is what makes this whole awesome thing possible. So thank you guys a lot for coming. I know your time is valuable. We really appreciate you being here. So today what we're going to look at is an introduction to the Docker engine, which is the actual mechanical bit that you interact with on the command line and through shell scripts or whatever. And then Docker Hub, which is our website and kind of cloud service revolving around Docker engine that sort of takes it from this solitary thing that you can use on your own and do cool stuff with to a big network of people that make Docker even more useful. So why are these two aspects of the Docker platform useful, and why are they cool? And then I'm going to go over kind of a basic usage section, which I'm really excited about, because I'm going to actually pop onto the CLI and then show you, like in the terminal, this is what it looks like to use Docker. These are kind of the basic mechanics of it, and you're going to actually get to see stuff in action. So that's really fun. So then I'm also going to go over a little bit of Docker orchestration with Fig, which is a tool that a company called Orchard, who is now a part of Docker, developed. So essentially what that's for is quickly running multi-container apps. So if you have an app with a lot of dependencies that all could run in different containers, Fig sort of provides a nice way to organize that and then make it very, very easy to share with other people. So that's what we're going to go over today. So quickly, though, before we begin, tell you a little bit about myself and why I'm kind of qualified to speak to these things. So I'm Nathan LeClaire. Hi. I'm a Linux and Unix-centric programmer by kind of profession and hobby. And so, I love Linux and I love open source, and I've been involved with that for a long time, a little bit over 10 years now. And I'm also a technology blogger, so I love writing about tech and sharing knowledge and, basically helping people to learn more about programming and about using the command line and that kind of stuff and be more effective at it and have more fun with it. And, also just general geek, pretty typical geek that likes Star Wars and all that kind of stuff. So I'm also a builder of Docker training materials, so stuff like this is really my bread and butter at the company. It's a big part of my role. So one of the ways that we make money, since we're an open source company that doesn't charge for the actual binary that you get and use, is we sell educational materials. So for instance, we just started promoting our independent Docker training course where you can pay to come and learn firsthand from the people who are right there on the front lines of the battlefield doing it, how to be very, very good and very, very effective at using Docker. So I'm part of the team that does that, and I'm also the first line of defense on customer concerns with the technology. So when we're talking to people and trying to convince them to use Docker or helping them with issues that they have if they're already using it, myself and a couple of the other guys on the same team as me are the first line of defense in terms of like the actual technical beef of helping people with that. So, and then just a fun little fact about me, I love writing, so I really, really enjoy writing. And I love playing music, so I play the guitar and sing, and I also love avocados, especially California avocados. So that's a little bit of a personable face to the guy who's giving you the Docker presentation. So, all right, so let's start with some questions. If you were like actually physically in the room with me while I'm giving this talk, I would have everyone raise their hands so we could sort of get a general perspective on what's the amount or portion of the audience that has actually tried these things. But since this is remote, you should, you can raise your hand if you want to, but you should just kind of mentally check off, yes, I have, or I haven't actually tried these things, because they're all great things to try if you're interested in Docker and interested in learning and experimenting more with it, because they all kind of present their own unique appeal. So I'm guessing that most of you have at least heard of Docker since you're here. So that's probably a fairly ubiquitous thing that we've all heard of Docker. So try the online tutorial. So we have a tutorial that you can go through online that kind of walks you through some of the basics of using Docker and is a really friendly way to sort of get started with it if you don't know how, or you may be a little bit intimidated by all of the complexities of installing it, which, with boot to Docker and stuff is actually a lot nicer than it used to be. And if you've installed and tried the Docker binary, that's another great way to sort of start getting used to it. Once you start to get the hang of like booting up containers and looking at them and stuff, there's a good chance you're going to have a lot of fun with it. I really, really recommend just jumping right in and trying the actual Docker thing. Maybe you've also used Docker Hub, which is a cloud service that we provide that's related to all the kinds of different things that you can do with Docker. And I'm going to go into that a little bit later on in the presentation. And then, the kind of holy grail is if you've actually run Docker and used it for development or for, QA or for CI or actually running it in production. So the bold ones, back in the day when Docker was in like 0.6, it's at like the 1.1 release now. People basically ignored the don't use us in production warnings and used this anyways, and they were kind of the people in the forefront of using the technology. And now more and more people are starting to use Docker in production, so it's likely that, if you kind of learn your way around doing that now, you'll get a little bit of an edge on the pack. So what is Docker and why does it matter, right? So what is Docker? So Docker is a company, but also it is a platform for building, shipping, and running applications in Linux containers, right? So the Docker engine, which I kind of described this a little bit already, but the Docker engine is like the binary that you interact with on the command line, Docker, right? And I'm going to show you actual, mechanics of working with it. But the engine is the binary that you interact with on the command line, and it deals with the actual mechanics of building applications and running them, right? So I'm going to cover a little bit of technical detail on that just to sort of pique your interest if you're interested in how things work under the hood, and you can go explore more if you want. And then the Docker Hub is the Docker Hub website, which you should totally go check out. It's at hub.docker.com, and I'm going to also talk a little bit about that in the presentation. And it deals with the community and the social aspects of, Docker. So like actually pushing around images, which images are sort of like templates that you use to make containers from, and some cool features like automatic building of images. Like when you push to GitHub. So we have a feature called automated builds I'm also going to talk about in a little bit that basically allow you to automatically create an image whenever you change your source code. But most importantly, Docker is a community that we would love to have you join, right? So Docker is a huge open source project. It is what I consider to be an example of a shining success in the open source field, just because it started as kind of a little project that Solomon, our founder, and some of his friends and people that worked for us were hacking on, and then they decided to, okay, we're going to open source this thing, which was sort of like Container Engine 2.0. They had written one for the original .cloud PaaS, and then they decided to sort of rewrite it and do all the things right that they didn't get to do the first time, and they decided to share it with the community, right? So nothing makes the Docker platform better than the community. It's definitely amazing to be a part of such a vibrant and active community and to be right at the center of it, and you guys can get involved too if you want. So that's really something great, because you can just look at all the code if you want, and you can contribute on GitHub. If you have issues, you will be heard, and other people might have those issues too, and you can find out about it. So Docker is a community that we would love to have you join. So I felt like obliged to include this slide saying, note, there's a lot more to a community than just code, right? There's kind of this, I feel like there's sort of an attitude sometimes in open source, ecosystems where, basically coding alone is glorified and the other functions like writing documentation or whatever aren't really as glorious. But I think that's completely wrong, right? And a lot of people have stood out and said that, like, there's a lot more to a community, an open source community, than just coding, right? That is part of it, but, honestly, coding is sort of like the tip of the iceberg of, like, this giant Docker project where there's all this other stuff going on, right? So even if you're not, like, you don't know Go, or you're not really sure how to contribute in terms of code, or you're not that confident, there's a lot of other ways to help, and we'd love to have your help on all of these. You can contribute to documentation. You can blog about your experiences using Docker, and I said pro tip, if you tweet at Docker, they will probably retweet you, and then you will be like crushed in a flood of favorites and retweets by all of the people who follow the Docker Twitter account. And you can hang out with us and ask questions on IRC and Twitter, and you can report bugs or issues on GitHub if you run into them, and other people will be so grateful for that, because especially if you find some sort of fix or workaround, you'll really help them out too. Because there's nothing more frustrating than sort of like Googling around for an issue and trying to figure it out, and like you can't find anything. So like filing issues on GitHub is really important. And then you can also make and share useful images, which I'll kind of get a little bit into what that means later. So all of these functions are capital I important. They're very, very important. So we would love to have your help. I just feel obliged to say, if you want to get in the community but you're not really sure how, there's a lot of different ways, and not all of them are code, right? Even the majority of them are probably not code. So why does Docker matter? Well, Docker has a lot of big wins, and it's got many, many advantages that are being explored in very vibrant and creative ways by people. So there's a lot of different things, but the primary advantages that I could kind of think of is that you can deploy everything with lots of control and flexibility, right? So historically, deploying stuff has been a really huge problem. It's a big pain. You spend 6 months writing everything and getting it perfect on your laptop, your Ruby on Rails app or Django app or whatever, and okay, now you want to deploy it, and you deploy it to your server, and everything's broken, right? And for like little hobby apps and stuff, this is a problem and a pain, but for big businesses, it's just the cost of deploying something, from moving like an app from one place to another, is astronomically high. So that's why the shipping container metaphor gets brought up a lot, is because it provides this nice unified, like, way of getting code and getting your app from point A to point B. So no matter what it is, you know, if it's like an application that will run on Linux, which most of like modern development is, you can deploy it, and you can deploy it to wherever you need to fairly seamlessly. So, you know, that includes web apps, so something as complex as like Facebook or Wikipedia or Twitter or what have you, that involves these huge stacks of different technologies that, you know, traditionally you have to rely on a variety of different solutions that have their own disadvantages to get them out into the world. And likewise for databases. And, you know, one big interesting use case is people are using Docker for kind of standardizing and making it easier to do big data processing. So, you know, if you have a complex technology stack that involves Hadoop and all this other stuff, you know, historically, because you have to run that on like 100 nodes in a cluster, that's a really big pain to get that all working. And then once you have it working, to try and move it somewhere else would be even more of a pain. And Docker makes that a lot easier and a lot more flexible. So it provides a nice process isolation abstraction that plays well with others, right? This is, in my opinion, you know, a good tagline for this is sort of like, it's just Unix, right? Like, there's nothing fancy going on. Like, there aren't any proprietary weird DSLs and stuff to learn. You can really start getting fluid and up to speed with Docker fairly quickly because everything sort of follows the Unix way. Like, we're very wanting to follow convention as much as possible to make things easier for people to get up to speed. And then, you know, there's no weird proprietary wackiness. It's all open source. And there's, like, not anything that, you know, is going to be a weird curveball if you're doing, like, networking. You know, if your application uses ports and standard in, standard out, and all of this kind of stuff that you're used to, well, Docker will probably work quite well with it. So under those bullet points I have, it loves both VMs and bare metal. It will run on a VM and on bare metal, no problem. It's just a binary. So, you know, one of the advantages of having the Docker client and daemon written in Go is that in addition to getting a really nice performance benefit from being a compiled language, you know, it will run on a huge variety of different platforms. So you can use, and then another thing that's really nice is you can use configuration management tools if you like them, or if you want to get rid of them, you can also get rid of them. So like things like Puppet and Chef and Salt and Ansible, a lot of people have a lot of buy-in to those tools, and that's fine. If you want to keep using those tools with Docker, we're not telling you chuck out Puppet and Salt and Ansible. We're just saying, you know, okay, here's one way to do it if you like that. So if you like configuration management, that's great. And it will also work if you, you know, write your Docker files just using apt-get commands or what have you. So that's one thing that's pretty cool, is it really plays well with others. And there's a very, very lucid summary of that in the README on GitHub if you're curious to kind of learn more. And so I hinted at this a little bit, but one of the big advantages that, you know, I'm getting at is you can escape dependency hell. So no more of this ugly, like, oh, I'm using a slightly wrong Ruby subversion and now all of my stuff doesn't work because it's like Ruby 2.0 versus Ruby 2.1 on my server, and oh god, these gems won't work, and oh god, what am I going to do? So that's no longer a thing, right? Like, if it works in the Docker container once, wherever you do it the first time, it will work the exact same way everywhere, and you'll have the exact same version of Ruby, and so on and so forth, if you're building your Docker containers the correct way. So it allows you to escape that kind of dependency hell, which is why, like, sysadmins are literally just, like, praising the gods or whatever, like thanking their lucky stars that Docker came around, because it makes all of this stuff so much less of a pain and so much more consistent. And so it allows you to escape non-repeatability because everything now is much, much more repeatable. That's a big, big win for continuous integration, for example. In a previous position, we would always have issues where we would have tests that failed on our continuous integration server, our little automated tests that ran our PHP code to check and make sure that it was right, and occasionally they would fail, and we'd all get nasty emails saying the build is broken, so something is screwed up, and then we would go and run these tests locally, on our own environments that we have, and they would pass. So how are we supposed to fix the broken test, right? And then you're like, okay, what if something's breaking in production and we can't duplicate it locally? Well, that's a huge problem because then we can't fix it, right? If we can't duplicate it, we can't fix it. I mean, you might be able to, but it's really a question of taking 2 weeks to fix it in a slow, painful dredge of trying to debug production versus being able to instantly duplicate it in your laptop or wherever and have it fixed the same day. So repeatability. Repeatability is a huge thing. It matters a lot, especially the more complex that your app gets. And then one of the greatest things about Docker, and I've already talked about this a little, is it allows you to leverage this very enthusiastic, fast-growing open source software community. So lots of people out there, they're all writing about Docker, they're very enthusiastic about Docker, and you can be a part of it. And as Docker grows, and if you buy into the community, you can easily be handsomely rewarded as it grows bigger and gets better, and new features and awesome stuff drops for Docker every month. So that's another big advantage, and that's another part of why Docker matters. Okay, so how does it work, right? You're telling me it does all of this great stuff, but how does it work, right? So it takes advantage of containerization technology. So there was work that was done on the Linux kernel to provide this sort of stuff starting around 2005. And so it provides lots of UX niceness on top of features that were borrowed from or inspired by FreeBSD jails, Chroot, Solaris Zones, and OpenVZ. Those are all technologies that influenced kind of the current implementation of what we're doing. And, container technology has been around for a little while, but it's really that Docker took an existing thing and made it nice and easy to use and portable. And so that's why there's so much excitement about it, and that's why Docker is doing well, because it took something that was already existing and then made it way easier to use for people. So now this thing that previously was only available to people who could sort of recite the arcane or esoteric commands and do all of this fancy stuff is now available to a much, much wider range and a much broader audience. So the way that containers work is they actually share a kernel with the host, and in some cases they share binaries and libraries with other containers to save space. We take advantage of a union file system to pull off that little trick. So the whole containers sharing the kernel with the host thing matters a lot because, for instance, if you want to run an infrastructure that's totally virtualized, you'll have 5 virtual machines. They're all running 5 separate kernels, and honestly, if those kernels are all the same, there's not necessarily any reason to have that many separate independent kernels running. There are lots of reasons why you would want to use virtualization to contain an app, but if you can share the kernel, if you can share resources, you can get a much higher density, and it's really good. So containers are sort of edging in on a lot of the things that traditionally people have used virtualization technologies for. So originally it used LXC, which is an acronym for Linux Containers, which is a Red Hat project under the hood. And now there is a swappable execution driver in libcontainer, which is the section of the code base that deals with all of the container stuff. And the default is a implementation in pure Go for containers called libcontainer. So libcontainer has the libcontainer exec driver, but you can also use LXC and then probably other different container technologies or engines in the future. So part of what makes Docker cool is that you can swap out different parts if, for instance, you have a specific reason why you would want to use LXC instead of something else. So let's take a look under the hood a little bit. I'm not going to really go into a very high amount of detail about how containers work, because I really think that for a 101, I'm just going to touch on it a little bit and let you explore if you're interested in sort of the low-level operations that make it possible. But I do think it's important to at least take a look at it so that you're not like thinking, oh, it's just magic or what have you. So how do containers work? So I mentioned in 2005 some work was starting to be done on the Linux kernel that eventually made this possible, and the two features that made it into the Linux kernel that made Linux containers possible were namespaces and cgroups. And so namespaces actually isolate processes. So basically what namespaces do are it tells the kernel, okay, for this process, when it looks around to see what the kind of environment it's running in looks like, it's going to think that there's actually a much smaller subset of stuff than there really is. So for instance, PID, when you're in your own PID namespace, you only see a couple of processes as opposed to like the 700 or so processes that are usually running, just as a normal part of your computer. Likewise, mount does that for file systems, net for the network, and so on and so forth. IPC for interprocess communication. And then there's a kernel feature called cgroups that allows you to have fine-grained control of resources in the kernel. So you can take a certain subset of processes and isolate them and make them say, okay, you can't see anybody else. And likewise with cgroups, you can say, and you can only use 256 megabytes of RAM, and you're pinned to one CPU core, so you can only use one CPU core, and or you have this relative CPU weight that dictates how much you're allowed to use relative to other processes and stuff. So that's kind of how those two things come together to make the basic idea of containers possible. And then Docker uses this thing called a copy-on-write file system to actually use disk efficiently. So for instance, if I have an Ubuntu base for one of my containers, and then I want to have another container with another Ubuntu base, well, if I don't ever modify anything in that base Ubuntu file system, if I'm only reading from it, I'm never writing to it, it doesn't make any sense to actually have another duplicated copy of that on disk. So what I actually do is I use copy-on-write to reuse that same stuff that was there for the other files, like in the other image. And then efficiently, you can use disk because you're reading from the same places, and then you only actually copy it over on disk if you attempt to write to it. So you would be changing it, so you have to copy it over. So we also have, so that's a little bit about Docker Engine and how it works, and I'm going to be exploring that on the command line with you in a second here. And we also have Docker Hub, which is a software as a service offering around Docker, and it's really fun. I highly encourage you to go and get an account, and as part of like playing with Docker, push and pull from Docker Hub. I mean, well, if you're pulling from Docker Hub probably, but push, and you get one free private repository, so that's really cool. So we have Docker Hub, which is sort of a GitHub-inspired software as a service offering around Docker. And so why is that useful? Well, Docker is a very powerful tool on the command line, but it becomes even more useful through network effects, like when you can actually use other people's images that they made, right? So if someone's made an image for a torrent client or PHP or Apache or Nginx, whatever it is that you want to containerize, if someone else has already made an image for that, it just makes sense to reuse it, so you don't have to reinvent the wheel. And also we provide images for you to use that you no, we're good. So there's a pull and a push mechanic similar to what you're familiar with from distributed version control. For instance, Git. With Git, you have a push, so you can push out your code to the server, and you can also pull down code that other people have made. Well, it's the same thing with Docker and Docker Hub. You can push out images and stuff that you've made to share them with other people and share them with the world. And you can also pull down stuff that other people have made and run it and do all kinds of cool stuff with it. So Docker Hub provides a central registry with verified and maintained base images for building other images from. So if you want to build a base on top of something that already has Node, for instance, or already has Ubuntu with all of the Ubuntu niceness, well, you can just get those from Docker Hub. We have a thing called the Stack Brew project that essentially the point of that is to create base images for everyone to use. And we also have paid private repositories if you don't want to share your images with the world. So like for companies and stuff, and even for just normal people just tinkering around too, if you store secrets in your images or whatever, or you just don't want to share your code, it's proprietary, it's not open source, then you can buy private repositories. And honestly, like for the prices that those are going for right now, they're a complete bargain. Like they're super, super reasonable. And you know, we're pushing a lot of bandwidth around on our CDN for how much we're charging. So private repositories, great deal, awesome way to use Docker but not have to share your images with everybody because it's public by default. It's sort of similar to how GitHub, you can pay for private repos. And there's also helpful features such as automated builds and webhooks, and then user authentication and authorization, so you can have user accounts. So automated builds are a feature on Docker Hub that allows you to track a repository that you have on GitHub or Bitbucket, and whenever it changes, whenever there's a new source code push, Docker Hub actually rebuilds the image. So then it's immediately available for anyone that wants to pull it down and tinker around with it, and like, you know, you don't have to manually maintain it and just keep pushing yourself. It's something that can be automated. So that's really cool. Likewise, webhooks and build triggers are features that can be used for automation. You can actually trigger actions, like for instance, running your test suite inside of continuous integration when the build is complete on Docker Hub, and so on and so forth. And more features are going to be added like that in the future, just to basically make it so that you can use Docker Hub to be very, very, very useful in your workflow and to get things out to production faster. Now we're going to come to the point that you've all been waiting for, where I'm going to actually show you around some basic Docker stuff. So the first thing I'm going to go over is Docker PS, which is a command for seeing the containers that are running, which there are no running containers right now, but you can see the headings on the table, so container ID, image, command, when it was created, the status, etc. It's all here, and that's the Docker PS command. And if you do Docker PS -a, you can see all of the containers that are running, or sorry, all of the containers that exist but aren't running. So these three rows are all containers that I have that aren't running right now. So the Docker PS command just lets you get your bearings really quickly. You can do Docker PS -a, and -l for last, or -q if you just want the IDs. And so Docker run is the command that you actually use to create and start containers, right? So you'll be doing Docker run a lot if you get into Docker. So what I'm going to do is show you very quickly Docker run -it. So I'm going to run it in interactive terminal mode, and I'm going to run using the Ubuntu base image, and I'm going to boot up bin bash as the process. So as you can see, I now have a terminal prompt, and this is a terminal prompt inside of a Linux container. So even though I'm on my MacBook, I'm actually in a prompt inside of this Linux container, and everything is there that you would expect to be there in your Ubuntu install. So we have apt-get, for instance, but we don't have yum, right? So I can exit out of that, and notice how fast this container gets created, right? This is kind of one of the very cool things about containers is they boot up extremely quickly. All of these are me creating a completely new container. Now, if you imagine trying to create a completely new virtual machine that fast, I mean, it's just night and day. Virtual machines are just not that quick. So you can see in Docker ps-a all of these Ubuntus that I very spammily created. And now I'm going to show you Docker run -it for interactive terminal mode CentOS. And we're going to enter in on bin bash also. So as you can see, it's similar looking, but not exactly the same because we're using CentOS as our base. And do we have apt-get? Nope, we don't have apt-get because apt isn't the package manager for CentOS, right? We have yum. See? We have yum, right? So you can pretty easily just create little containers, and to be fair, I have already pulled those base images so they boot up super fast. Normally the biggest part of like what takes time for creating new stuff is just downloading the actual images, but I have those ready to go. So as soon as you have them actually downloaded, the boot up is really fast, right? So Docker run -it CentOS bin bash. I can create another CentOS container, and it goes very quickly, right? And so this is really nifty. You can create all kinds of different stuff, and it's really cool because, for instance, if I'm like, oh, I just want to create a new container. Oh yeah, well that little shortcut's not going to work. But so like you can boot up and create containers really fast. So it's kind of cool because you can like spin something up, try it out, and then just get rid of it. Because containers are so ephemeral, like that it's really no skin off your nose to just get rid of it and then start a new one. So that was an interactive mode. So you can do interactive mode with containers, and you can also do running them in the background. So if you do Docker run -d, that's for detached or demonized mode, which will run a container in the background. So I'm going to show you this little trick, right? So Docker run -d Ubuntu is the base image. It's going to be an Ubuntu-based container. And what I'm going to do is shell -c, while true, do echo hello world, sleep for 1 second in between each one, and do done. So I'm actually telling it to run a series of shell commands, and I get back this container ID, right? And so if you look at the next step on the list, Docker logs is the next thing, which allows you to actually look at the container output from what you just initiated. So if I look at Docker logs of this container ID, you can see that that is the actual hello world. And so what's kind of really cool is that this container is its own unique thing with its own network interface, its own process isolation space, and it doesn't affect the host at all. So like if I look at Docker PS, I can actually see this running. And likewise, there's a command Docker inspect to look at a container, and that will print out a big old JSON dump. But you can see, for instance, this container has its own unique IP address that's assigned to it automatically at runtime. So this container, for all intents and purposes, I don't want to say it's exactly like its own machine, since we definitely don't encourage people to think of containers as just a replacement for VMs, but it's its own sort of self-isolated process of doing stuff. So, so now we can see this running in Docker PS, and I can do Docker stop to actually stop it. Or kill it if it's being stubborn. There we go. So I have Docker kill for this, and then there's also Docker remove. So remove a container because they all just hang around unless you get rid of them explicitly. So kind of a cool little trick is if you do Docker ps -aq, it gives you just this list of container IDs that are around, and you can do Docker remove of that command using a subshell, and it will just remove them all. So now if I do Docker ps -a, there's nothing there, right? I removed all the containers, but I still have images, many images. So images are sort of like templates or stencils that you use to create containers from, right? So the way that you build images is with Docker build. So I'm going to show you what it looks like to do a Docker build. And the way that you do builds is you have this thing called a Docker file. So I'm going to look at this Docker file for this really quickly and show you. So this image comes from a base image that's called Node that provides you with Node.js and NPM and all that kind of stuff for building Node apps. You can just use that as your base image, and this is a image that we provide using the StackBrew project that I mentioned. And so this is a Docker file which has its own very simple little language for dictating how to create images. So we say from Node. So start with the Node base so that we have access to, for instance, NPM. So we run npm install -g HTTP server. I add this presentation. I add the current directory to /presentation in the container, expose port 8080, and make my work directory /presentation, and then say, okay, container, when I boot you up, run the command HTTP server to serve all the static files. So I'm going to show you what a cached build looks like. So the way that you do a Docker build is Docker build -t for tag, Nathan LeClaire, which is my name, /reveal101. Nathan LeClaire is my username on Docker Hub, /reveal101, and dot, which is the build context, which is the current directory. So when I do this, it uploads the context of the current directory to the Docker daemon, and then it runs a build, which it uses the cache for the whole time, basically. Well, not all of it, actually. It just runs really quickly. But so you can see that there's a series of steps, and each step creates a layer in an image, and I can now use that image to do things. Right, so I created an image called Nathan LeClaire /reveal101. So I can do Docker run -it, Nathan LeClaire /reveal101, and also I want to say use the -p argument to actually expose a port from the container. Let's see, actually. Yeah, so I'm going to do Docker run -p, and I'm going to forward port 8080 from the container to port 3000 on the host, and I'm going to run this image, Nathan LeClaire reveal101, which is the it's an image for the slideshow that I'm running right now. So as you can see right here, I'm running this on localhost, right? Like I'm just running it locally. But if I go to boot to Docker 3000, it's the same presentation, right? It's the exact same thing. It's just running inside of a container. So I could actually ship this around and share it with anyone, anywhere, and it would work the exact same everywhere, and it would be done kind of exactly the way that I like it. So, if someone else used this image, they could easily boot up this presentation, serve it, whatever they want. So that's Docker build, just at a 10 at a glance. I'm going to end that. And so I'm going to talk a tiny little bit about Fig and then take some questions. So Fig is a tool that a company called Orchard developed, and Orchard is now a part of Docker. So now Fig is an officially Docker endorsed tool, and what Fig does is it takes a configuration file that's written as YAML, and demo, so Fig. So it has a fig.yaml file, which essentially dictates, okay, these are the services that make up my multi-container app, and these are how they sort of interrelate or fit together. For instance, expose this port off of this app, this is the command that you should run when you start up this container, and link this container from, like, we want to create a link to the Redis container from the web container, which contains our actual app. So the thing that's cool about Fig is just, you have this complex stack of stuff that ties together in various ways that you want to sort of codify in a file, and you just type Fig up. It creates the containers and boots them up and prints this nice, like, multiplexed log of their output. So this is a Python app, Web 1, and this is Redis 1, which is the Redis container, which could easily be a database or anything else, or you could have Redis in a database and Memcache, or do whatever crazy thing you wanted, and all link to it using the YAML file. And then what you can do is you can actually access that app, and you see this app says, hey everyone, I've been seen 1 time, 2 times, 3 times. I'm refreshing the page right now. So every time you hit this page in the app, it actually increments Redis, which is running inside of a container. You can see the source code for the app if you're curious right here, and it's also on the Fig website. And you actually increment Redis and you spit out, hey everyone, I've been seen this many times, where it's the value in Redis. So I killed Fig, so this won't be running anymore. But that's a basic summary of Docker and kind of the cool things around it and how to get started with it. So that's all, folks. Go forth and Dockerize. So, so the GitHub URL is github.com/docker/docker. We would love to have you join us on Docker channel and Docker-dev channel on IRC on Freenode. And then likewise, if you're interested in libcontainer or libswarm, which are 2 sort of separate components of Docker that have been split into their own thing now, those also have their own channels on IRC on Freenode. Docker Hub is at hub.docker.com. I highly recommend you go get an account and sign up for the newsletter and take it for a spin. It's really nice. And also, these slides are available online at nathanleclaire.github.io/docker101-talk. So don't be afraid to poke me if you have a question. And I think I'm going to go ahead and take some questions now. Yep, we got a pretty good amount of time. We got 12 minutes. So I think in the Ready Talk there should be some questions. I'm going to actually go back. Yeah. Okay, cool. So, okay, so questions. So this is a chat, but here's the questions. So, all right, so question. When creating containers, is it best practice to create a separate container for each typical build component? For instance, have a container that just has Tomcat, have a container that just has MySQL, a container that just has Apache HTTP, etc., and link them together. So asked by Jason S., and the answer is yes, Jason S. That is the best practice. So there's a variety of reasons which have been elaborated on quite a bit that I won't go into too much here, where basically the way that we recommend people structure applications is like that, to have everything in a separate container, right? So the idea is not necessarily to have one process per container, which you may have heard, but to have one concern per container. So, you keep your server separate from your database, separate from your web app, and you just link them all together using the primitives that you have available. And so the reason for that is just because it basically promotes a nice separation of concerns, and then if something goes wrong with one part of the application, you just have to kill that container and restart it. You don't have to like kill your whole app and reboot it, or like try and debug in this like messy stack of stuff where you're using initd and all this stuff. So yes, we recommend like one concern per container and just link them together. Any plans to port boot to Docker to FreeBSD, whether it uses VirtualBox or jails? So boot to Docker in particular, I don't know that it's very high on the priority list, but I do think we would like to support BSD eventually. I think it's more feasible to have like a VirtualBox implementation on FreeBSD than it is to have like a jails like exec driver for libcontainer, because there's sort of some things with jails that don't really map to containers exactly. So there are plans. People would like to do it, do that kind of thing, get Docker on FreeBSD, and it's not a super high priority, but we would like to do it. We're just quite busy. So do people take advantage of SANs while using Docker? I must admit my ignorance on this SAN. So what's a SAN? Service area network? All right, I'm just going to skip that question for now. Maybe chat will say? No. I have to admit my ignorance. I don't know. What does that stand for? All right. Okay, so Rick Evans asks, storage area network. Okay, so basically, I'm not aware of anyone using Docker for that in particular, but one of the nice things about Docker is that it's being used for so many different things. So I have to admit ignorance on that one. I'm not aware of anything, and in fact, obviously, I didn't really know what a SAN was. So I have to just say I don't know, but I would love to hear about it if you hear of anything. So shoot me an email, Nathan@Docker, if you come across that. And thanks, chat, for helping me out. Anyway, so Rick Evans, context matters. Can you be clear what machine you are running the commands? So I'm running the commands on my Mac, and the thing is that we have a Docker binary where the client actually works on Mac, but it communicates to a remote daemon, which is also the Docker binary, running on a virtual machine, right? A small little virtual machine whose only purpose in life is to run Linux, to run Docker, and that virtual machine is inside of a VirtualBox installation that's managed by a tool called boot2docker that we provide. So basically, I'm running the actual Docker commands on my Mac, but they're talking to a remote Docker instance that's running inside of a virtual machine, because you have to have a Linux kernel. You're basically completely tied to the Linux kernel for now, at least. So what is the difference between image and container? So you can kind of think of this like an image is like the stencil that you use to actually paint containers, right? And containers are like the actual sprayed result of like painting into that stencil, right? So a container is a actual booted up version of the image, and an image is just the basic sort of set of files and stuff that dictates, okay, this is what the container's environment is going to look like when you run it. So how do you get back into one of those running containers, asks James Sparenberg. So James, the way that you get back into one of those running containers is that you actually have a command called docker attach. So just to show really, oh wait, you're not looking at my screen anymore. The command is docker attach. So you just do docker attach ID, and then you're popped right back into like standard out of the container. So Kevin Ridgway asks, is the intention that Fig will remain a separate tool, or do you see Fig being rolled into the Docker CLI? The dream is to eventually have features like that inside of Docker itself. Right now, there's all sorts of various issues with that, including that we're all really busy and we're all super paranoid about letting stuff into the Docker core that's not like verified and vetted and true. Because it's a lot easier to keep stuff out than to let it, well, sorry, it's a lot easier to wait to like bring stuff in than to like get rid of it once you have it. Like we decide, oh, that's a horrible decision. Well, it's too bad you already let it in. So the dream, though, is to have Fig-like functionality inside of Docker. It may not necessarily be Fig itself, but we would like to do something like Fig inside of Docker. So Augustin Haller asks, which is the best provider I should deploy Docker to? EC2, Heroku, etc. So the thing about that is that Docker runs pretty well everywhere. I really think that the best environment where you would get the most wins for having it would probably be, you know, like I know that DigitalOcean's a pretty popular choice. They have pre-built Docker images where you can just like spin up a little droplet with Docker ready to go, so that's pretty cool. But you know, it runs just about everywhere that's Linux, so like I would probably go with, I guess, EC2 or like DigitalOcean. I like Linode too. I've got to give Linode a shout out. I have a Linode. That's where I keep all my stuff. So Heroku, I think, is more for people who don't want to mess with their own like configuration stuff. So like Dan Silberman asks, what if you do want a difference from the dev environment and prod environment, like what is logged, etc.? So what you would do in that case is you would actually have two separate Docker files, and basically those two separate Docker files dictate the difference in the way that that behaves. So one Docker file sets configuration options that says, okay, log this, and one says, don't log this. And you would just build two separate images and use like make or bash scripts to sort of manage that. So Scott Radven asks, what real-world scenarios are you getting the most feedback on? How are people using Docker in production beyond what most tutorials show? So there's a variety of things. One area where just about everyone seems pretty comfortable jumping right in is with continuous integration. So having Docker for your CI is a really big win. A lot of people are really, really happy about using it for that. Just because, you know, you can get super consistency and super repeatable builds. So a lot of people are using it for that, and we even have a demo that I didn't do today, but that we do sometimes where we sort of demonstrate, all right, this is us pushing like code to GitHub, and then it automatically gets built as a Docker image, and then Jenkins automatically pulls it and runs the tests, and if it passes, we deploy it out to like 3 different cloud providers. So it's really easy to deploy to like 3 different places. And so that's another thing, is just if you have anything where you need to have really consistent stuff, or you know, also if you need better density, like if you have 5 different things that you want to run in their own sort of separate isolated things, but you don't want to use VMs because like your laptop would just grind to a halt, like Docker's really good for that. So let's see. Question, how did you get boot to Docker, the domain, to resolve to the Docker VM? What I do is I have a little trick where I edit my /etc/host file, and I add an entry called boot to Docker, and it points to the actual IP address of the boot to Docker virtual machine. Full disclaimer, sometimes that IP address changes, so if you do that, be aware that sometimes that IP address might change. You might have to edit etc hosts again. So I wrote an article actually called 10 Docker Tips and Tricks that will make you sing the whale song of joy, where like I go over that if you're curious. Let's see. Imran Ansari asks, did you run Docker directly on OS X without Vagrant and VM? The answer is, without Vagrant, yes. Without a VM, no. What we're doing is using a tool called Boot to Docker that Docker provides that runs an actual instance of the Docker daemon inside of a VirtualBox instance. So it's a VirtualBox instance running TinyCore Linux, which is a small little Linux distribution. And basically, the only thing that that VM does is run Docker. So you talk to the, you do actually run the Docker binary client on OS X directly without Vagrant and VM, but without a VM, but you're actually talking to a remote Docker daemon that's running inside of the virtual machine. So what's the best way to have 2 or more processes running in one container? Well, we don't really recommend it, but if you do want to do it, I would use something like initd or supervisord. So that's basically how people do that if they're going to do that, but you probably shouldn't do that. So Sam Zadel asks, expanding that FreeBSD question, how about Solaris zones, or specifically Illumos support? So that's definitely one of those things where we'd love to have it, and we super welcome contributions, but we are all like super busy and have a ton on our plate, and we really want to make everything stable and working really, really well on Linux first before we like explore that kind of stuff. So, all right, we're running out of time, but I have just 2 more questions I'm going to try and zip through. So, I have CentOS image in AWS with all my applications configured. Is it possible to use that AMI in Docker, or I have to use Docker repository image and reconfigure one more time? So, I guess theoretically you could use that AMI in Docker, but like then you would be running like a VM in Docker, which I don't know if you can do like AMIs inside of Docker. But the thing is that you know, however you're like creating that AMI now, it's very likely that the translation over to like building that with a Docker file is not that painful, because Docker files kind of you can run like you can write them sort of like elaborate shell scripts, honestly. And you can use configuration management stuff if you want, if you have that already. So, last question, Maximilian Hack, really sweet name. What is the best practice for database servers cluster? I.e., should the containers connect to the cluster, or should they use proxy containers? So basically, if they're on the same host, like if they're on the same machine, it's probably fine to just have them connect directly. If they're connecting across hosts, you should probably use the ambassador pattern, which seems to be what you're sort of alluding to with using proxy containers. So there's a thing called the ambassador pattern that we recommend for communicating across hosts, and that's probably what you should do if you want to talk across hosts. On the same host, it's fine. You can just link them directly. So, all right. Oh, Imran Ansari says, you guys rock. Thanks. Thanks, Imran. You guys rock for coming. I really appreciate everyone coming today. And we're all done with the presentation. And so thanks, guys, so much for coming.
Ladies and gentlemen, that does conclude the webinar for today. Thank you for joining. You may now disconnect.